So this is 9.5a, elementary algebra, and this section is called complex numbers. Oh golly, complex numbers are basically all the numbers that you ever deal with, plus more. And what we're going to be working with, and sometimes they're not all called complex numbers, sometimes they're called imaginary numbers. And a lot of students are like, oh, crud. Not only do I have to deal with the numbers that exist, but now I have to deal with numbers that don't exist. And that's kind of true. So the complex numbers that we're going to be dealing with is called, actually, it's called the number. I'll see if I can say this without you being like, okay, you're crazy. Is the number I. Okay, just like we have the number pi represents 3.1415 undo infinity. The letter I, lowercase, script like that, represents a number. And it represents a number that really doesn't exist. The square root of -1. Because if you remember, whenever you have a negative in a radical sign, it doesn't exist, right? I had you put down the null set or no answer or something like that. Now that we're in this section, and we're toward the end of elementary algebra, we're going to introduce an answer that doesn't exist, and it's called I. Because what happens? We can take square root of 9 and get 3, right? But the square root of -9 means what two numbers multiplied together give me -9? There isn't one, because -3 times -3, negative times a negative is a +9, not a -9. And +3 times +3 is a +9. So there is no number multiplied together that gives us -9. So it's an imaginary number, or a complex number. All right, so I represents the square root of -1. That's very important to remember, because as we go through this lesson or into the next lesson, that will be very important to know that. And I'll show you some real quick and easy ways to simplify these that I don't know that the book even talks about. But a complex number can be written in the form of a plus bi. That's called the standard form. Now, this form is not as complicated as what it seems. It just says that every number can be written that way. So this is a number, and this is a number, and then the I is just the I. So if I want to write the number, or if I give you 3 plus 4i, that is the standard form of writing a complex number. You don't understand what that is at this point, but that's okay. If I have the number 12, that's also a complex number, and that can be written as 12 plus, do you see an I there? No, 0 i's. Or what if I had a 4i? Do you see a number all by itself there? No, so it's 0 plus 4i. So it's written in this format, a number plus another number, a number plus another number times I. So 12 can be written as just that number and then no i's. Or the 4i can be written as a 4i added to no number there, no number all by itself. So anyway, that's what that is. And kind of important to see that, but it won't be like tons and tons of stuff over that. So we're going to add and subtract complex numbers. Example 1. Adding and subtracting complex numbers is very, very simple. It's just like adding. You basically pretend that, and I know this isn't real mathematical jargon here, but you kind of pretend that that I is a variable. Okay? You only add like terms. So if you want to take out the parentheses, and you combine the 3 and the 2, and you combine the 4i and the -6i, and that's it. Okay? So it's not a variable, but you work with it as if it is a variable, and you should be fine. So 5 minus 4i minus 6 minus I. Remember, when you take the parentheses off and there's a negative in front of it, you have to change the sign of everything in the parenthesis. Now I can go 5 minus 6 and get negative 1. Negative 4I plus I is negative 3I. And it always is listed in that order. The number by itself first, and then the imaginary part of it goes last. So let's keep going with example 3. 2 minus 5I minus 3 plus 7I plus 2 minus I. Again, we're taking the parentheses off. Minus sign there changes the sign of everything there. We combine our numbers with no i's. 2 minus 3 is negative 1 plus this 2 gives me a 1 for my numbers. So that's gone, and that's gone. Now I have negative 5i, negative 7i, and a negative I, which gives negative 5 minus 7 is negative 12, minus 1i is negative 13i. And you're good to go there. So, again, if you just treat these i's as if they're variables, as far as adding and subtracting, you're fine. Now let's go to multiplying. Same thing happens here when we multiply. Distribute 12i plus 20i squared. Okay, now here's another little secret here. I equals the square root of negative 1. I said that at the beginning. I squared equals negative 1. Because what happens here, what if we multiply this by itself? What if we square it? What do we get? We get the square root of negative I, the quantity, or negative 1, the quantity squared, right? And when this number and this number are the same, remember, everything goes away and it's left with negative 1. So all that to say, and I would just remember that. I mean, it's not a real hard thing to remember. I squared equals negative 1. So what I'm going to do here, instead of an I squared, I'm going to put a negative 1 there. So 12i minus 20. And then we got to switch these around because the number always goes first, like that. Okay? All right, let's try another one. And this one, we're going to use the FOIL method. So let's go FOIL. First, outside, inside, negative 6i times I is I squared. Alright, so 12, I'm going to combine those. Minus 6, and I squared is negative 1. So 12 minus 1i plus 6, because these two multiply, two negatives, and you can get rid of this here. 12 plus 6 is 18. And there you go. That's it. Alright, example 6. One of the things that's important as far as complex numbers is you can't have a complex number. You can't have an I in the denominator, just like you can't have a radical in the denominator. So we're going to get rid of this complex number here, so we don't have this. And how do we do it? How did we do it when we had things like 2 over 3 minus the square root of 5? We would multiply top and bottom by the conjugate. Where the 3 and the square root of 5 stayed the same, we just changed the sign between them. It's the same thing with imaginary numbers. In fact, they call it a complex conjugate. So what we're going to do is we're going to multiply top and bottom. Okay? And when you multiply by the conjugate, if you remember, you square the first number, square the second number, 2i, 4i squared, and you put a minus sign between them. And then you have to multiply these using the FOIL method, which becomes 10 minus 4i plus 5i minus 2I squared. All right. Now, why did you do that? Because I squared is negative 1. So this I squared here will change to a negative 1. Whoops. So let's go ahead and do that. We're going to write the numerator as 10, and we're going to combine these two, plus 1I minus 2, and this I squared changes to a negative 1, over minus 4 times this I squared changes to a negative 1. So we have 10 plus I plus 2, two negatives give you a positive. 25 plus negative 4 times negative 1 is 4. So 12 plus I on top and 29 on the bottom. And that is what we have for an answer. But remember, we have to write our answer in A plus B I. So we're going to split those up. So we're going to split the 12 over 29 plus the 1 over 29. So we split them up to look like that. And I think the book doesn't even split it up to look like that. I think they write it as 1 over 29I. So this 1 over 29I they put as a fraction here, and the 12 over 29 goes here. So you just split these up and put them both over the 29, and you're good to go. All right, so that is the first bit of complex numbers. Hopefully you're not finding them to be too ridiculously hard. It's kind of taking a lot of stuff that you already know and applying it to this. So I don't think you have any trouble with 1 through 18. 19 through 30 I can't see that you'll have any trouble with. You know, maybe 31 to 38 might be a little tricky, so let's do 38. 3 plus 2I over 3 minus 2I. Multiply it by its conjugate. Okay, so we're going to do the FOIL method here. So we get, I'm going to do it below here in yellow. First, outside, inside, last. And on the bottom, we just square the first term minus square the second term. And then that gives us 9I plus 12I. Oops, sorry, this isn't an I there, is it? Plus 4 times negative 1, replace I squared with negative 1. 9 minus 4, replace that I squared with negative 1. And that gives me 9 plus 12I minus 4 over 9 plus 4. So 9 minus 4 is 5 over 13. Okay, so then we split those up to 5 over 13 and 12 over 13 with an I there. So it looks like that. And that's it for 9.4. And I said at the beginning this was 9.4a, but there isn't a 9.4b, so we're just going to call it 9.4.